Hello everyone. Today I wanted to present you this book on basically the universe and with some really nice description and pictures also. As you can see, my cat thought she would make an appearance again. We'll see if she stays in the picture or not. Okay, so first of all, this is a book I got secondhand, I think 4 years ago. So as you can see, the colors have passed on the side, so maybe we'll try to find out when it was printed, what years it is from. First information, it was printed in the USA. I don't know how it made its way to the little town in France where I bought it. Okay, so I do not see any date for the printing, maybe at the beginning of the book. Okay, 1979. First published in 1979. So maybe it was printed after that. There's no date about the printing. Okay, then I think we can start by reading this description of the book to begin with. Okay, so let's see. Catalogue of the Universe by Paul Murden, Royal Greenwich Observatory, England, and David Allen, Anglo-Australian Observatory, Australia, with original photographs by David Malin. Malin. Anglo-Australian Observatory, Australia. Before the virtual revolution in astronomy of the last few years, the universe was almost the exclusive property of astronomers and astrophysicists. Speculation about the nature of stars, the possibility of life in outer space, the origins and nature of quasars, pulsars, supernovae, and white dwarfs, the existence of black holes, the extent and shape of the universe, and the origin of our own planetary system was confined to a scientific elite and filtered down to most of us only as science fiction. Now the universe has become a common property. Space exploration is a reality. Information from X-ray, cosmic ray, neutrinos, space probes, ultraviolet wavelength, radio waves, and the most powerful optical telescopes is flooding in from the deepest parts of space. theories and models are emerging to account for the most unlikely phenomena. We are on the verge of a fundamental shift in our understanding, comparable to the leap forward that occurred in the Renaissance. This is a change of knowledge which reflects on our origins and on our basic concept of nature. It is of great importance to all human culture. The Catalogue of the Universe is a collection and a portrait of the best known, the most unusual, the most remarkable, and the most interesting of all that we know about, or at this moment can know about in space. Each object is described in terms the layman can understand. Each is illustrated with unique photographs, some prepared by a new technique that has never been used for a popular book before this. Many of these photographs are in brilliant color. This is the only catalogue work available that gives us all a full picture of the nearly unimaginable universe that is now becoming a real permanent feature of our understanding. It is an important new reference source and a highly original book written for the layman by distinguished professional astronomers. Okay, so let's bear in mind that this book is about 40 years old, so I guess we've discovered many things from this time, but still think we'll be able to get some nice pictures and maybe some nice description also. Let's read some of this part. Okay, so the universe of galaxies. This is a photograph of a small patch of sky. If you were to stretch out your hand and at arm's length, a finger would just about cover the actual area of sky shown. In this patch of sky, the unaided human eye would see nothing, for none of the stars is bright enough to be seen. But by using a telescope as a giant camera and keeping the shutter open for a long time to record faint images, many stars and astronomical objects become visible. Although this is only a tiny part of the sky, it is fairly representative of the sky as a whole. It is, however, the only photographs in this book which has been chosen to show nothing in particular. So what does it reveal? Even a glance shows that there are two types of objects. The circular, compact dots are stars, while the fuzzier blobs, which are not always circular, are the much more distant galaxies. The star images vary in size, some being as much as a few millimeters across, but these images do not represent the true size of the stars. The spreading of light in the photographic emulsion and in the telescope, and the turbulence of the Earth's atmosphere through which the photograph was taken, combine to enlarge the star images. If these factors could be bypassed, the diameter of the star image would be 10,000 times less. The slender spike on the brighter star images are also an artifact of the telescope. They are caused by the spreading of the starlight around the struts for the assembly which hold the photographic plate and are called diffraction spikes. There are diffraction spikes around the fainter star images too, but these are too faint to have been recorded. Despite their faintness and tiny apparent size, the stars on these photographs are all objects very like the Sun. Indeed, many are actually larger and brighter than our Sun. It is only because the Sun is so close to us that it is so prominent in our lives. The stars on these photographs are tens of millions of times farther away than the Sun. The galaxies are yet more remote by a similar factor. Knowing that they are much more distant, yet that they appear only a little fainter than most of the stars, indicate that galaxies are intrinsically much brighter objects than stars. In general, galaxies achieve this enormous luminosity not by being larger versions of stars, but by containing hundreds of millions of stars. These individual stars in a galaxy are widely separated. So even at their extraordinary remoteness from us, the galaxies have appreciable size. They can therefore be distinguished from nearby stars. To write the distance of these galaxies in miles or kilometers would need 23 digits. It is more convenient to use light years, which are based on the travel time of light. 1 light year is the distance light travels in 1 year. About 10 million kilometers. Galaxies can be photographed several billion light years away. By comparison, the Sun is only 8 light minutes away, and the Moon a little over a light second away. The light travel time bears another related piece of information. How long ago the light we are recording began its journey. As we examine objects at a great distance, we are obligated to view them in the past. Many of the galaxies in this photograph are seen as they were a billion years ago. If you want to know how they look now, we must wait a billion years for their light to reach us. Stars exist only in galaxies. Although galaxies appear numerous on these photographs, they only occupy about 100 millionths of the vast volume of space of the known universe. The view of the sky from a typical point in space is empty of individual stars, and usually only distant galaxies can be seen. But our own sky is full of stars, as shown on these photographs, which indicates that we live in a privileged space in the universe. Far from being in a random part of empty space, our environment is atypical of the universe. This is not surprising, since without the Sun there would be no life, and the Sun, being a star, lies in a galaxy. From our special position, not only we are able to look out on the multitude of galaxies, many like our own, and learn of their nature and variety, but at the same time we can look into our galaxy and discover an even greater variety of objects. The pages of this book are a gallery of what we find. Let's watch some images. I'll stop if I find something particularly interesting. This spiral galaxy is beautiful. Let's read a bit about our galaxy, the Milky Way. The Milky Way is the band of light from the distant multitude of stars of our galaxy. Though each star is too faint to be picked out by eye, together they glow visibly. Swamped by bright lights from the city, diluted by moonlight, the Milky Way can best be seen from country areas around the time of new moon, particularly in summer and winter when it arcs from near the celestial pole to the northern and southern horizons. The Milky Way exists because stars in our galaxy are not equally distributed in all directions. The galaxy is flattened like a pie, and there are fewer stars visible when one looks through the thin dimension of the galaxy than through the thick dimension. A being living on a planet circling a star in the middle of a spherical galaxy, which would have equal dimension in all directions, would see no Milky Way at all. His sky would be equally bright everywhere. If his sun were off-center, the sky would be brighter on one side, towards the center of his galaxy, than on the other, but there would be no band of light. The existence of the Milky Way shows us that we live in a very flattened galaxy, like the spiral galaxies we've seen on page 16. Not only does the Milky Way represent the presence of stars, it corresponds to an absence of galaxy. While galaxies are found elsewhere in the sky, they are not found near the Milky Way without the so-called zone of avoidance. The reason for the zone of avoidance is that the dust concentrates in the plane of the Milky Way. We cannot see through the dust toward the galaxy, which are certainly beyond it. In the last section we showed how stars and gas exist in enormous collections called galaxies. It is time now to see how stars exist within each galaxy. It is only recently that astronomers have had large enough telescopes to study individual stars or small groups of stars in galaxies beyond our own. Thus, most of our knowledge of the kinds of smaller collection of stars comes from studying the ones in our own galaxy. There is an immediate problem. We can say that all the stars in a distant galaxy are at the same distance and belong to that galaxy because we can see that the stars are separated from other nearby galaxies by the enormous distance of intergalactic space. But the view we have of the stars of our own galaxy, as seen from inside the galaxy, is far more confused. It has always been difficult for astronomers to disentangle chance, line of sight coincidence of stars from real groups. In the following section, we see how it is possible to separate the real groups from the apparent. I know this one. You can see a horse head inside the nebula. This one you can see also. Horsehead Nebula. Dark, dusty droplet. This Horsehead Nebula is a dark dust cloud in the shape of a horse head and neck, which protrudes into the bright emission nebula known as IC 434 in the constellation Orion. It is virtually opaque, as there appear to be no stars visible through it. IC 434 emits light because of the energy input into it by the nearby star Sigma Orionis. The color picture, plate 13, shows that the IC 434 emits red H-alpha light in contrast to the blue reflection nebula in the dark half of the picture. Zeta Orionis, easternmost star of the Orion's belt, is brighter than Sigma and nearer the nebula, but it is less effective in emitting the ultraviolet light, which causes nebulae to shine. IC 434 is expanding and colliding with the large cloud of dust which fills the eastern quadrant of the constellation of Orion. Dark half of the picture. The presence of the dark cloud can be seen in the way it cuts down the number of stars visible behind it, compared with the two halves of picture. The boundary of the cosmic collision between dark cloud and nebula can be seen as the bright rim of IC 434, which abuts onto the dark cloud, center across picture. In the collision droplet of the dense dark cloud are penetrating the less dense lighter nebula, like oil poured into vinegar salad dressing. The horsehead is the largest known of these elephants' trunks of dark material. At a later stage, the droplet detach from the main body of the dark cloud when they are called globules. Some astronomers think that this may be the first stage in the formation of some stars, though others believe that the globules will eventually disperse into interstellar space. The American astronomers Henry Curtis and John Duncan used the horsehead as the first proof that the dark nebulae were not due simply to the absence of stars. Said Curtis in 1918, "It is impossible to look at the horsehead and not be convinced that there is something dark between us and the bright nebula." Let's read about Tycho star. What is this drawing? Okay. Renaissance supernova. Although nova means new, a supernova is in fact a dying star. The energy of its explosion is far in excess of that of ordinary novae, which is why the phenomenon is called a supernova. Most stars fade relatively quietly into white dwarfs, perhaps puffing off a planetary nebula as a dying gesture. Massive stars do not go gentle. They rage against the fading of their light, exploding with an energy which, for a few brief days, can outshine the galaxy in which they occur. Stars of a large enough mass to produce supernovae die in each galaxy the size of ours once every 30 years or so. A seventh of these become visible to the naked eye, judging by the fact that 5 have been noticed in the last millennium. But the exploding remnant gas clouds which the galactic supernovae leave behind can be identified in our galaxy and are known to astronomers as SNRs, supernovae remnants. Most of our knowledge about supernovae themselves come through observing their occurrence in the many galaxies outside ours, but also from historical records of supernovae in our galaxy, such as Tycho star. Although the first observation of the brilliant star, which appeared in 1572, was made by a Sicilian mathematician named Francesco Moraligo. The star was named after Danish astronomer Tycho Brahe, since his observations of it were more systematic. This star is one of only 5 supernovae seen in our galaxy in the last 1,000 years. Tycho supernovae reached the apparent brightness of Venus in November 1572, when it was visible in daylight. It gradually faded throughout 1573 and became invisible to the pre-telescopic astronomers in March 1574. It was particularly important in the history of astronomy in that it remained fixed in the sky in relation to the other stars of the constellation, Cassiopeia, which surrounded it. Thus, it had to be a true star, not a planet, not a comet. Yet many people thought that the stars were eternal. The changes they saw in the supernova in 1572 and Kepler's supernova of 1604 hastened the revolution in astronomy, which culminated in the general acceptance of the Copernican-centered theory of the solar system. Tycho Brahe made a series of detailed measurements of the position of the stars with the new sextant-type instrument, which he had just finished constructing. Other astronomers in the day, Titches and Mastlin, also made measurements of its position. Thanks to them, the position of the supernova is well known. In the same area of the sky in 1952, radio astronomers R. Enbury Brown and Cyril Hazard found an intense radio source. They were deliberately searching for the remnant of the supernova. Their discovery was thus different from the accidental discovery of the radio remnant of the Crab Nebula. The radio remnant of Tycho supernova has the form of a hollow shell caused by the still expanding pressure waves from the explosion in 1572. In 1959, MT Paloma astronomer Rudolf Minkowski found extremely faint, optically visible filament in the region of the shell, still moving outwards. In 1967, X-rays from the hot gas at 1,000,000 degrees Celsius were discovered by a rocket-borne X-ray sensitive telescope. Tycho supernova is the clearest example of a supernova and its remnant, with a direct line through 400 years of astronomical observation. I'm glad I read this part, I thought it was very interesting. Let's read a bit about the Sun. We know more about the Sun and its immediate environment than we know about any other star. This is not surprising, as the Sun dominates our view of the universe. Indeed, we live inside its atmosphere. This star, our star, travels around the galaxy together with a multitude of lesser companions bound to it by gravitational forces. The largest of the orbiting bodies we call planets, most of which are in turn orbited by smaller moons and satellites. These objects, together with many lesser masses, are known collectively as the solar system. Planets are not unique to the Sun. Large planets can be detected around some of the very nearest stars, like Barnard's star, and it is highly probable that the planetary system accompany a large proportion of stars in this and other galaxies. In some young stars, like MWC 349, we found evidence of large amounts of gas and dust lying in flattened disks, and these we believe to be in the earliest stage in the formation of planetary systems. It so happens that conditions on one of the Sun's planets were favorable to the establishment of a special kind of chemistry with large and complex molecules capable of replicating themselves and adapting to different environments. This phenomenon, which may be rather rare in the universe, we call life. It is not possible to assign a meaningful probability to its occurrence on any other planet around any other star. Since some of the chemicals which can form the primitive building blocks of life have been found by radio astronomers in clouds of molecules in space, it seems unlikely that life is unique to our solar system. However, we have no means of detecting its presence elsewhere in the universe unless that life has developed sufficiently to generate, intentionally or otherwise, radiation which can be distinguished from cosmic sources. Thus, we have a highly biased view of the distribution of life. solar system is almost confined to a single plane, the elliptic, and eventually from a disk-like nebula. The mechanism by which it is formed is fairly well understood. A cloud of gas collapsed under its own gravity to form a central condensation. Prior to its collapse, the gas must have had a certain amount of swirling rotation. We can measure the swirling by a physical quantity called angular momentum, which depends both on the rotation speed and size of the object. According to physical laws, angular momentum can never be destroyed. As a gas cloud becomes smaller, it must spin faster to conserve its angular momentum. In the same way, a periodic ice skater speeds up when she pulls her arm onto her side. The rapid rotation prevented the solar nebula from total collapses into one object. A core did form, rotating fairly slowly, which eventually became the Sun. The remaining gas lay much further out, retaining most of the angular momentum of the original cloud. Although this prevented the gas from falling in towards its axis of rotation, nothing stopped it shrinking in a direction along that axis. Under its own gravity, therefore, it collapsed to form a disk. The collapse modeled in miniature the formation of a galaxy. Okay. Here you can see the Sun's disk and the X-ray of the Sun. I advise you really to get this book because I cannot read it all to you, but there are some very interesting paragraphs I'm not reading you right now. And it's an old book. I think you can find it secondhand quite easily, especially if you're from the US. Now they're talking about all the solar system planets. Even Pluto. Sorry, Pluto. It's awful what happened to you. Oh, and they're even talking about some aspects of the Earth, such as the Cape Verde Island, Red River, Himalayas. Very interesting. Okay, let's read. Let's read something about the moon. The moon, Earth satellite. Our Earth, in common with most other planets, does not travel alone around the sun. It is attended by a single satellite, which we call the moon. The Earth makes up for its lack of number of satellites by the moon's size. The average retinue in the solar system is rather more than 4 per planet, each with a mass which is thousands that of the planet. The moon, however, weighs almost 1/80th as much as the Earth. This distinguishes it from all other solar system satellites, except the newly discovered companion to Pluto, which are minuscule compared to their parent planets. For this reason, the moon is sometimes considered to be a separate planet, which was captured by the Earth after its formation. However, the law of physics makes such a capture quite difficult, and astronomers are not in agreement about how and where the moon originates. With a diameter of 3,500 kilometers, the moon is smaller than any planet except the remote Pluto, which is not a planet anymore. It has been enabled to generate enough heat from the decay of its radioactive materials to power prolonged volcanic activity, although it has experienced an era of volcanism. Today it is a dead, rocky planet, with only a very small core accounting for about 4% of its mass. The moon is too small to retain an atmosphere. And that's it. That's it. You've seen the book from cover to cover. I hope you've enjoyed the few readings I've made and the pictures you've been able to see. If you've enjoyed the book, don't hesitate to find it for yourself so you will be able to read it completely. I do believe that even though it is basically science, it's also very poetic and very interesting for you to understand a bit more the universe and what's surrounding us. Thank you very much for watching, and I'll see you very soon. Thank you.